Lesson 4.2, Parabolas. In this lesson, you're going to learn some new important vocabulary that would be focus, focal length, and directrix. We're going to start with a parabola that the vertex is centered at 0, 0. So here's the general equation in vertex form. By leaving the vertex at 0, 0, that equation will simplify to y equals ax squared. Now there's some information about parabolas that you weren't told about in Algebra 1 that we're going to expand upon in Algebra 2. And the first is the definition of a parabola. The correct definition of a parabola is a set of points equal distance from the focus and the directrix. Now you may be saying, okay, what's a focus and what's a directrix? So my vertex is at 0, 0. The focus is a certain set of units on the axis of symmetry, but a certain distance that we call P from the vertex to the focus. And the directrix is the exact same distance that we're going to call P on the other side of the vertex. The directrix is this imaginary line. The focus is a point. Now, by the definition of a parabola, if we choose any point on the parabola, so if I chose that point, or if I chose this point up here, that it is going the distance from the focus to that point, and from that point to the directrix, those are going to be the exact same distance. Or if I chose, let's try a different point. If I chose this first point I chose, so this distance to the focus, and then the distance to the directrix, those would be the exact same measurement. So you can think of the focus as the point inside the parabola, and the directrix is kind of on the outside of the parabola. So let's look at the equation for this parabola. So we said that the equation is y equals ax squared. Well, it turns out that this coefficient a, now you already know a little bit about that number. If that number is a positive number, the parabola is going to open upward. If this a is a negative number, it's going to open downward. Well, something else interesting about that coefficient on x squared is that it's related to the focal length. And this a right here is equal to 1 over 4p, which p is the focal length. So if I come over here to the graph, this distance, okay, from the vertex to the focus, we call that the focal length, p. And just like in the slide before, we also know that this distance is also p. So if we know the focal length, p, then we can substitute in that value, 1 over 4 times p, and get this coefficient for x squared. If we know the coefficient, then we can actually solve for the focal length if we don't know what the focal length is. We can also know that the focus, then, the coordinates for it is 0, p, and the directrix, since it's a horizontal line, will be y equals negative p. You will also commonly see this written as 4py equals x squared. So simply multiplying both sides for 4p, you get these are equivalent equations. We can also find the inverse of a parabola by switching the x and the y. So we're going to put x here and y here, and that gives us x equals ay squared. And that gives us a parabola that actually opens to the right. And notice that this parabola is not a function. It would not pass the vertical line test, which is why we're including it in this section on quadratic relations. The equation for this parabola is similar in that it has a focus, in this case right on the x-axis, and it has a directrix. In this case, this distance is the focal length, as well as that distance is the focal length. The equation is very similar, in which is x equals 1 over 4py y to the second. It kind of got cut off. Okay. The focal length, again, is p, and our focus now would be at the ordered pair of p comma 0. And the directrix is a vertical line, so that vertical line is x equals negative p. Similarly to the other parabolas, if this coefficient here is positive, it's going to open to the right. If this is a negative value, it's going to open to the left. So let's go to the handout that you received in class. At the top of the page, you'll see a diagram with all these new vocabulary words labeled. You've got the focus, you have the directrix, you have the general form, where we can also write that, if you're more comfortable, as the right pen here, y equals 1 over 4p x squared. So these are equivalent. Let's go to the middle of the page and answer some of the questions. So question 1, we're given the equation x squared equals 32y. I'm going to actually come down here and I'm going to rewrite that as 1 over 32x squared equals y. And our first question says, how can you determine in which direction the parabola opens? Well, this number right here, 1 over 32, is positive, so it's going to open up. Next question, what is the focus of the parabola? Okay, focus, if you remember correctly, it's 1 over 4p x squared equals y. That's our general formula, so that we can set these coefficients equal to each other. So 1 over 32 equals 1 over 4p. Cross multiply, I get 4p equals 32, and p is equal to 8. So I can write the focal focus. Actually, that's the focal length. So the easiest way to figure this out is to kind of sketch out the graph. We know that vertex is at 0, 0, and we know it opens up. And now we know that the focal length is 8, and our focus has to be on the inside of our parabola, so it's going to be right here, and the directrix is going to be somewhere down here. Now we know that the focal length is 8, so this distance right here is going to be a total of 8. So that gives me an ordered pair then of 0, 8. The directrix is going to be the same number of units in the opposite direction. So that's going to be the horizontal line y equals negative 8. If you sketch out a picture of the parabola, it's going to help you write these coordinates. Going on to question 2, we're given another equation of a parabola. Again, I'm going to rewrite that as y equals 1 over negative 48 x squared. It says, what is the value of p for this parabola? Well, again, we're going to set that coefficient. Negative 1 over 48 is equal to 1 over 4p. Okay, cross multiply. I'm going to put that negative with the negative 1, so it becomes negative 4p equals 48. Divide both sides by negative 4, and you get negative 12. So the value of p for this parabola is a negative 12. So let's think what that negative 12 actually means. That coefficient is negative, so if I was to sketch this out, so it means our parabola is opening downward with the vertex going through 0, 0. It also means then that my focus is somewhere in here, and my directrix is up here. So that will actually help me write the coordinates for the focus. Since I know the distance from the vertex to the focus is 12 units, in this case in the negative direction, that's going to list our focus at 0, negative 12. And then my directrix, which is a horizontal line, will be y equals a positive 12 because it's in the opposite direction. If you will turn that handout of notes over to the back side, which is blank, I want to do another problem with you. In this case is where we're going to actually write the equation for parabola. We're going to stay with the vertex being at 0, 0. And you're going to be given the focus and the directrix and asked to write the equation for the parabola. I highly recommend when you get to these kinds of problems that you sketch out a graph of the parabola, because you need to look at the information you're given and figure out, well, which direction does this parabola open? Does it open up, down, left, right? And the information about the focus and the directrix will give that to you. So I'm going to plot the focus. The focus is at 2, 0. So right here is my focus. My directrix is a vertical line at -2. So right about here. Okay. That means that my parabola, which is the vertex at 0, 0, it cannot open up or down. It can only open to the right, because our focus has to be inside the parabola and the directrix on the outside. Once I have it sketched, I can give the general form of that equation, which is x equals 1 over 4p y squared. This is one of those inverse parabolas. I can also count what the focal length will be. That will be, I'm going to label it p. That's a focal length of 2. So I can just substitute in 2 for p. So 1 over 4 times 2 y squared. Keep simplifying. X equals 1 over 8 y squared. Now if you look in your textbook, they actually are going to rearrange that and make it 8x equals y squared. So both of these are equivalent. So here's my advice for writing quadratic equations that involve information about the directrix and the focus. First of all, look at the information that you're given and sketch a graph. Plot that focus, plot the directrix, and then figure out, okay, which way is the parabola opening? Is it opening up, down, left, or right? Because once you know that information, then you know the general form of the equation, whether it's going to be x equals 1 over 4p y squared, or is it going to be y equals 1 over 4p x squared. Then calculate your focal length. You might be able to count it right off the graph. It might be given in the information.